Hi everyone, today we've got a differential calculus paper 2 style question. So, a particular park consists of a rectangular garden of an area A meters squared and a concrete path surrounding it. The park has a total area of 1200 meters squared. The width of the path, the concrete path, at the north and south side of the park is 2 meters. The width of the path at the west and east side of the park is 1.5 meters. The length of the park along the north and south sides is x meters, where x is greater than 3 but less than 300. First thing, write down the length of the garden in terms of x. Well, we can see that the length of the entire park up here, the length of the entire the length of the entire park is x meters. And you can see down here that this width is 1.5 and this width over here is another 1.5. So I'm going to have the length of the garden is going to be x minus 3 because 1.5 times 2 is 3. Next, find an expression for the width of the garden in terms of x. So back up to my diagram, I've got the area of the entire park is going to equal 1200. It says up here in the question that it's 1200. And area is length times width. So the length of this park is x meters, so I'm going to have x, and the width of the park, I can just say that the width of the park is, let's just say w. Let's say w. However, we have got, or what we are interested in, is we are interested in the width of the garden, right? So the garden is just this part in here. So if I say that that's W, then the length, or rather the width of the entire park is going to be that W there plus 2, because 2 meters is the width of the concrete path, plus another 2 down here. So now this is going to be plus 4, because 2 plus 2 is 4. Now let's rearrange this. Let's get 1200 divided by x equals the w plus 4. W, remember, is the length of, is the width of just the garden. Now we're going to minus the 4 across. So 1200 over x minus 4 equals the width of the garden. So back to my answer down here. Let's do 1200 over x minus 4 equals the width, and just for specificity, let's say the width of the garden. Okay, hence show that the area equals 1212 minus 4x minus 3600 over x. So as soon as the question says show that, you can't use this. You need to show in another way how that answer has come to be. Well, we know that the area is length times width. So the length was x minus 3. So I'm going to have down here area equals length times width. Area equals your answer for part AI up here. The length of the garden is x minus 3. So instead of length, we've got x minus 3. And instead of the width, we've got that number from AII. The width was actually 1200 over x minus 4. Now let's expand this. So we are going to have, let's do this maybe in a different color. We're going to expand. We're going to do x times 1200 over x. This is going to be 1200x divided by x, and you can see that the two x's are going to cancel in a second. Now let's do that x times the negative 4. So we're going to have negative 4x, negative 4x. Then let's do negative 3 times that first part. So negative 3 times 1200 is going to be negative 3600. So negative 3600 all divided by x. And then the last thing we're going to have is negative 3 times negative 4, which is positive 12. Okay, let's simplify. So 1200x divided by x is just going to be 1200. Minus 4x, we can just leave as minus 4x. Negative 3600 over x is, well, there's nothing we can simplify, and then plus 12. Okay, 1200 plus that 12 is the only thing that we can change, so 1212 minus 4x minus 3600 over x. And now what we have just figured out is the same as what it was asking for us in the question, so that is that answer. Next part. Find the possible dimensions of the park if the area of the garden is 800 meters. We just figured out a function for the area of the garden, which was my answer up here. That's what we figured out. So now we can let that equal 800. So 800 equals 1212 minus 4x minus 3600 over x. Let's go equation solver. So equation solver, and you can see I've already typed it in. So 800 equals 1212 minus 4x minus 3600 over x. Press solve, and we get an answer of x equals 9.64. That is not the full dimensions. That is just the value of x. So we need to now figure out what the width is. So if we remember before, we had area of the total park is 1200 meters. I've circled it right at the top. And we are trying to find the dimensions of the park. So you need to be a little bit careful because there's multiple shapes going on. So a quick little sketch of what we had before. We had the area of that entire park, and we said that was x, and we didn't actually define what the width was, but I can just say the width. So that whole area, all of that area was 1200. So now I can say 1200 divided by x, which is 9.64, is going to give us the width of the entire park. Again, that's different from the width of the garden, but for this question, we just want the dimensions of the park. So, calculator. 1200 divided by 9.64 equals this number. So the width of the park equals 124.48, and we are in meters. So the length of the park, 9.64 meters, let's say, and the width of the park is 124.48 meters. Now, I know what you're thinking. You're thinking that doesn't quite make sense, right? Because the length is only 9.64 meters, but the width is massive. However, within the context of the question, this is the answer that it comes out to. So we can check this. 9.64 multiplied by 124.48 That equals 1199.98, which really would be 1200 meters if I didn't round those two numbers. So I know that doesn't quite make sense. However, like in the real world, it doesn't quite make sense. But within the context of the question, these are the only numbers that we can go off. So the width is 124.48 meters and the length is 9.64. Next part, find an expression for dA dx. So let's just write this again. We've got area. I'm not finding the derivative yet. I'm just finding the area. 1212 minus 4x minus 3600 over x. I'm still not finding what's going on there? I'm still not finding the derivative yet. I just want to rearrange this. So 1212 minus 4x minus 3600 times x to the negative 1. Now I will take the derivative. So dA dx equals, if we're taking in the derivative, then any constants disappear, and we do our little rule for derivatives, which is you take the power of x and you multiply it by the coefficient. So that first term, 1212, is going to cancel itself out. X to the power of 1 times negative 4 is negative 4. And then we're dropping the power by 1. So x is now to the power of 0, which is just 1. So x is going to disappear. Next part, negative 1 times negative 3600 is positive 3600. X to the power of negative 1 minus 1 is negative 2. So negative 2. Next line, let's just tidy this up a little bit. dA dx is negative 4 plus 3600 divided by x squared. Okay, use your answer from part C to find the value of x that will maximize the area of the garden. So we need to essentially find a stationary point. If you have forgotten, the derivative is just telling us the gradient at a particular point. So if my graph looks like this, right at that point up here, the gradient right at that point would be 0, and that is a maximum. So let's see what happens if we let the derivative equal 0. So I'm going to say 0 equals negative 4 plus 3600 over x squared. Another way we could do this, by the way, is if we go graph mode. Let's graph this. Let's delete these two things. Let's do negative 4 plus 3600 over x squared. Let's draw this. We may need to just change the view window a little bit. Let's do negative 10. Let's do negative 100 actually, to positive 100. And let's do same for this, negative 100 to positive 100. Okay, exit, draw, G-solve. Let's do an X calculation when Y is 0. And we get an answer of positive 30. So all I've done here is graph. I have graphed that function. I have solved for x when dA dx equals 0, and it has given me an answer of x equals 30. X equals 30. Another way that you could do this, so I'm trying to show you multiple ways of doing this, is equation solver. Let's do 0 equals negative 4 plus 3,600 over x squared. Let's solve this, and you can see we also get x equals 30 up there. So there are a few different ways of doing this. Either way, I'm looking at the marking scheme right now. So you get a correct answer of x equals 30. If you said that x was equal to negative 30, you don't get a mark for that, even though my calculator just gave me an answer of negative 30, because in the context of the question, x cannot be negative 30. It's impossible to have negative 30 as a dimension. So you could only accept positive 30 as an answer. Find the maximum possible area of the garden. Okay, let's have a think about this. The area of the garden, back to where I found the area of the garden, which was up here, 1,212 minus 4x minus 3,600 over, was it x squared or was it just x? It was just x over x. Okay, let's let x equal 30, because we just figured out that the area, that the maximum area occurs when x is 30. So we're going to have area equals 1,212 minus 4 times 30 minus 3,600 over 30, and let's see what we get. Minus 972. So area equals 972 meters squared. Okay, that one is worth 2 marks. You get a mark for, let's see, you get a mark for substitution of your x value, and then you get a mark for the correct answer. This question, in general, you are going to need to find stationary points at some point, usually. You need to be careful with the question. Is it asking for the area of the garden? Is it asking for the area of the park or of the path? Those specifics were probably the hardest part of this question.